Equipment and instrumentation. Digital imaging. Um, any image on a computer screen is considered a digital image. A digital image is made up of pixels. A pixel, the word pixel, is short for picture element, and a pixel is just a small square. So here we have an image, and so a digital image is made up of all of these small squares. So each small square is a pixel. And all of these pixels together is called a matrix. And so a matrix are the rows and columns of pixels. A term used in digital world is dynamic range. This is the range of exposures that can be captured by the detector, by the image receptor. And what we need to know is that digital has a wider dynamic range than film. And what that means is digital, it's kind of saying that digital is more sensitive. Digital is better able to detect the differences in that signal and display them as different, meaning different shades of gray. So here's an example, and this is very hypothetical. So let's say we do an x-ray, and let's say there are 10 single x-ray photons that exit the patient to strike the image receptor to make an image. So let's pretend that the x-ray photon, let's say the x-ray photon number 1 is equal to an exposure of 1, x-ray photon number 2 is equal to exposure of 2, and so on and so forth. Okay, so if we use a film receptor or a film cassette, that film receptor would only be able to detect x-ray photons number 3, 4, 5, 6, 7, and 8. Whereas the digital receptor is going to be able to detect all 10 of them. So that's, again, what we're saying is that it's more sensitive. It has a wider dynamic range. So the dynamic range of digital is wider. So again, the digital receptors are able to detect a wider range of radiation, and so it can display that range as well, meaning different shades of gray. It can detect all 10 differences, and so it can display all 10 differences. Whereas film, it's not as sensitive. It only detected 8 of the 10 exposures. Data acquisition. So we just need to know what the word data means. Data in this case is the remnant radiation coming from the patient. So that is the data, or that is the signal. That is what ultimately makes up the image. Whereas another example, like in ultrasound, so in X-ray world, the data is the radiation. In ultrasound, the data or signal are sound waves. So it's just, so your input signal just depends on what you're using. Post-processing, this is something that is possible with digital equipment. Post-processing is not possible with film, meaning after you have an image on the screen, you can make that image lighter or darker, and you can't do that with a film. Once you have a film, it comes out of the processor, that's it. There's nothing you can do to manipulate it or make it different. Post-processing, there's lots of different terms. Windowing refers to changing the brightness and contrast. So if you change the window level, you're changing the brightness. So if you increase, if you are increasing the brightness, you are making your image lighter. If you decrease the brightness, you're making your image darker. And then if you change the image's grayscale, which is the same as contrast, you do that with window width. So if you want your picture more gray, you change the window width. If you want your picture more black and white, again, you change the window width. So using the window level and window width, that is called windowing. Archiving. Archiving just means to store, and so to store digital images is different than storing films. Digital images can be stored on tape, CD, a flash drive, things like that. Also, there can be several sets of original images, Whereas remember in film world, that one single piece of film, that is the only original. And so they can often be lost and they're hard to transport. Whereas digital images, there can be multiple originals, they're easily transported. The term PACS is Picture Archive and Communication System. So that is the system that we use to store all of our images, the PACS system, Picture Archive and Communication System. Quality control, that is regular maintenance and quality assurance tests that have to be performed on the equipment. Mainly the display monitor. So we have this SMPTE pattern, and this is what it looks like. And this is, again, it's an image, and it's used to calibrate and evaluate the monitor's brightness, grayscale, and also the spatial resolution, which means detail. So in digital world, the word detail is spatial resolution. So this pattern, this test pattern, is what the medical physicist would use to calibrate the display or the monitor. They would also use a luminance meter or photometer, and again, this is a device that measures the amount of light coming from the monitor. Another big factor in digital imaging and display is the ambient light, and that is a source of light not coming from the monitor. So that would be, your overhead, just the lights on in the room. And that light, that ambient light, should be kept at a minimum because it can interfere with the perceived brightness coming from the monitor, and it can cause glare. And then we have post-processing. Again, this is what this is one of the advantages of digital, is that you can manipulate the image after you have it. And so again, you can window, which we've already talked about. You can change the brightness and grayscale. You can do 3D reconstructions. You can magnify, zoom, annotate, meaning you can type on the image. You can invert the image inversion, which means when normally bone shows up white, you can switch it and make the bone show up black, and you can switch it. And edge enhancement, that is good for detail when you're looking at like extremities and things. So it doesn't really pertain to us in the vascular lab, but still it's a type of post-processing. Okay, moving on with equipment. An important piece of equipment in the vascular lab is the automatic pressure injector. And what those do is they allow for consistent, more precise injections than hand injections. The main parameter is the flow rate, and that is how much, the volume of contrast per unit of time. It's usually cc's per second. So, for instance, 20 cc's per second, or 5 cc's per second. They have, all automatic injectors have 4 basic parts. The control panel, so that's the touch screen where you set the parameters. Then you have the syringe, of course, which actually pushes the contrast. It holds the contrast in, has a plunger that pushes the contrast out. Has a heating device, and that heats the contrast to decrease the viscosity. Viscosity refers to thickness and stickiness. And it has a high pressure mechanism, and that is the mechanical part that actually, this is the mechanical part that actually pushes the plunger within the syringe. Injections can be done at low pressure and high pressure. Again, it just all depends on the parameters that you set. All catheters have a maximum pressure rating, meaning that they should not be used above a certain PSI. The automatic pressure injectors have a pressure limiting device. This is a safety feature so that pressure never exceeds a certain amount. An acceleration regulator, all automatic pressure injectors have that as well. This allows the injection to be accelerated gradually to avoid catheter whip. and which could damage the catheter and the blood vessel. Okay, briefly, I'm going to talk about the percutaneous equipment used in a vascular interventional lab. First of all, percutaneous, you need to know that that refers to via a needle or via a small puncture in the skin versus cutting down, which would require like a scalpel and a large incision. You've got needles, of course, this goes without saying, but the choice of needle depends on the procedure. All needles, though, are measured in gauge, and it refers to the lumen diameter. The larger the number, so like a 22 gauge needle actually has a smaller diameter than an 18 gauge. An 18 gauge needle has a larger lumen than a 22 gauge. The bevel is the distal angled tip of the needle, then there's the shaft, and then the hub, and that is the proximal part of the needle, and it usually can connect to a tubing or syringe. Here's the different types of needles. You have vascular access needles. I remember, and when we are performing vascular access procedure, that procedure is called the Seldinger technique. Then you have other procedures, non-vascular access needles, meaning, like if you have to do a percutaneous liver or percutaneous kidney procedure. There are biopsy needles, and then in some instances, the doctor will want micropuncture needles, which is basically the same setup. They're just, as they kind of refer to, they're just a lot smaller. Okay, then there are catheters, and a catheter is just basically a long, hollow plastic tube. They are measured in French sizes. Catheters are sometimes referred to how much torque they have, which means the ability to turn and twist as the doctor would like. There are angiographic catheters, and then there are drainage catheters. The angiographic catheters, those can be broken down into diagnostic and interventional. Diagnostic, of course, is meaning to diagnose or to try to define what the disease is. Interventional means to fix. And those catheters, so if it's a diagnostic procedure, those catheters are different than the interventional catheters. Interventional catheters, there are guiding catheters and other types like balloon catheters, like angioplasty catheters. Guide catheters, as compared to diagnostic catheters, they have a larger lumen and they're stiffer, so that contrast can still be injected when there's equipment within the catheter and to provide support. The wires used, a wire in a vascular interventional lab is composed of a core called the mandrel, so a mandrel core with a tightly wrapped spring around it. And these, of course, come in all different shapes and sizes. The diameter, your normal catheter would be like an 035 or 038, which that would be diagnostic. And then, of course, your interventionals sometimes are smaller. The length, again, just a regular, what we consider a regular wire would be 150 centimeter length, but they can be up to 300 centimeters. They can have that core, that mandrel, could be movable or non-movable. They could be coated with like a Teflon or heparin coating or not. The stiffness of the wire, and then the tips comes in all types. So they can be tapered, they can be straight tip, they can be J-tip, they can be floppy, they can be stiff. All different things with the wires. Then we have a sheath, and a sheath is basically just a small catheter that holds the vascular access. It often has a one-way valve, so what that does is it allows for vascular access, and we can put catheters and wires into the sheath, but blood won't come out. So that's what's meant by a one-way valve. You can put things in, but blood won't squirt out the end. And they often have a sidearm tubing, and that's so that you can hook up to blood pressures, so you can monitor the blood pressure, and also to flush the sheath.